Okay. Yeah. So good morning, all of you. I welcome you all to this first lecture on probability and statistics. So am I audible to you at the first? So am I audible to you? Okay. So whoever is not there for yesterday's class, so we'll quickly go through the things. So I've defined what is a random experiment for you, correct? So what is a random experiment? The experiment, good morning all of you. So the experiment for which the outcome is uncertain. Correct? This is what we have seen in yesterday's class in the last 5 minutes. So for which the outcome is uncertain. So examples, if you see, rolling a die and then flipping a coin. You can keep on writing as many number of examples as you could wish to do. Okay, so in yesterday's class we have seen different examples and we have talked about few more things as well. So next we would like to define something called sample space, which I have also defined in yesterday's class. So I'm just quickly recalling the things that we discussed yesterday so that you'll be having a clear idea if someone is not present for yesterday's class. So sample space is the set of all what happened to this board again? Just a second, guys. The set of all possible outcomes. The set of all possible outcomes of a random experiment. The set of all possible outcomes of a random experiment is called sample space. Is called sample space. It is denoted by ES. Correct? So now if it is denoted by S, so for example, if random experiment is flipping a coin, I'm just quickly writing the things that we discussed yesterday. So if the random experiment is flipping the coin, then S is equal to set of head comma tail. Okay, and I think we wrote one more thing. If random experiment is rolling a dice, then S is equal to 1, 2, 3, 4, 5, 6. Okay, of course this is the case when you are rolling a single die. When you are rolling multiple dice, we have other things as well, because when you roll 2 dice, there are 2 possible outcomes in every set, correct? So whoever is not present for yesterday's class, so if you quickly recall, we have discussed what is a random experiment. So random experiment is basically the experiment in which the outcome is uncertain. Means in a particular trial of the experiment, you're not sure about which particular outcome is going to come, but what are the all possible outcomes for a particular random experiment, correct? And that's why we say the outcome is uncertain. And these are 2 examples. We have discussed 2 more cases in yesterday's class, so I hope you remember them. So sample space. So sample space is nothing but the set of all possible outcomes in a random experiment. So if you are conducting a random experiment, then all the possible outcomes. Means, for example, if you are flipping a coin, there are 2 possible outcomes, correct? What are they? Head and tail. So we write all these outcomes, head and tail, in a sample space, and we denote the set containing all the outcomes with this S, where S corresponds to this sample space. Similarly, sample space changes from experiment to experiment. If your experiment is flipping a coin, then sample space consists of 2 elements, basically this head and tail, and sample space consists of 6 elements if you are rolling a single die, and 1, 2, 3, 4, 5, 6 as well, things like this, correct? So did you all remember till this moment? So can I start today's class from this? Actually, these 2 definitions we discussed in yesterday, if you remember. Okay, clear to all of you? So shall I go ahead now? Okay, so now let us define one more thing, which is called event. event. Okay, now what is event? It's not something similar to Jabardast and all that you see, but event is any subset of sample space. Any subset of sample space is called an event. Any subset of a sample space is called an event. It is denoted by E or A or S, I mean B, whatever you want, some capital numbers you can denote, E1, E2, whatever. Okay, so now if you talk about few events, examples of few events, example, since I'm going with these two random experiments since the beginning, I would like to write appearing of a head when a coin is flipped. Okay, so basically when you flip a coin, you have two possible outcomes. What are they? Either head or tail. But out of this either head or tail, if you call this occurring of a head, then you know this head is a subset of this sample space, correct? So occurring of a head is an event. Similarly, you can call any of the events. Like for example, when you are rolling a die, occurrence of an even number, then you see 2, 4, 6, which is a subset of this, total sample space. Yes, we call that as an event. So any subset of a sample space is called event. Okay, so see here. Now we'll see something called odds in favor. Okay, before going for odds in favor, let me define you what is probability. So now we'll go for probability of an event. So what is, I think, can you see the board clearly? Is some part missing? I guess no, correct? So fine. So probability of an event. So event is nothing but subset of sample space. So if you want to talk about probability of an event, the probability of an event A is nothing but the chance of happening of A, which you already know. So the probability of an event A is nothing but the chance of event A to happen at that moment is given by P of A is equal to number of elements in S, where S stands for sample space. Yes, so see here, number of elements in S that favor occurrence of A, divided by total number of elements in S, which is sample space. So if you see, divided by total outcomes. So favorable outcomes divided by total number of outcomes. Means, for example, if you see, if I ask you an example, see here, the probability of appearing an even number when a dice is rolled. If I ask you this, when a dice is rolled, if I ask you this, see here, yeah, numerator is basically event. Okay, so denominator is total sample space. So see here. So now if you write random experiment is rolling a dice. Of course, a single die, rolling a dice. Otherwise, I could have stated a pair of dice or 3 dice, something like that. But if I'm mentioning only die, it's a 1 die. So random experiment is rolling a dice. So what is the sample space now for this random experiment? 1, 2, 3, 4, 5, and 6. Correct? Now, A is the event of getting an even number. even number. So if you write the set A with all favorable outcomes of A, when you roll a die, if 2 appears, then your event occurring an even number gets satisfied. So 2 is one favorable outcome to make this event appearing of an even number happening. Okay, so appearing an even number is the event that you're talking about, and this 2 is one of the outcome in the sample space which could favor this event. Similarly, 4 is one more outcome of this sample space which could favor this event. Similarly, 6. So if you see 2, 4, 6 are the events, are the outcomes that favors this event A. So if you write cardinality number of A, this is called cardinality number, which means basically how many elements are there within a particular set. That number is called cardinality number. And you know, if there are 3 elements, we denote n of A is equal to 3. And this implies n of S is equal to 6. So this is basically the definition of n of A divided by n of S. Means number of elements in set A, where A is the set containing all favorable outcomes, and n of S is the number of elements in sample space where S corresponds to a given random experiment. So if you see, this is 3 and this is 6. So this implies probability of getting even number. Since I have denoted this with A, we can write straight away probability of A is equal to 3 by 6, which is 1 by 2. Okay, so this is the basic definition of probability when you have a random experiment associated with a certain outcomes. So did you all understand the basic definition of probability? What could give us the expression for probability of an event? So it's nothing but number of favorable outcomes divided by total number of outcomes. Of course, this is a easy question. So just by looking at this question, you can tell the answer is 1 by 2. But when questions are a bit difficult or a bit next level, then we could always apply this definition to get the probability for simple events. Okay, next. So if you see this, next we'll go for, we have seen what is an event. So then we'll go for something called axioms of probability. Axioms of probability. What are called axiom? What's the main difference between axiom and theorem? Can anyone tell me that? What's the main difference between axiom and theorem? So please tell me, what's the main difference between axiom and theorem? Please tell me. There is no proof. So generally for theorems, you can start with some basic procedures and you can show that the results are correct. But axioms, they can't be proved mathematically. Like they are correct by default. For example, if I say you sun rises in the east, there is nothing like proof for that. One day you'll take me in the morning, correct? It happens daily, so you can see that. So some phenomena, they are correct by default in this nature. So if you see, there are no explanatory proofs for them, but these statements are generally correct. So I would like to show you that. 1. If A is an event, within a sample space S, within a sample space S for a random experiment, then one thing that happens by default is 0 less than or equal to number of elements in A less than or equal to n of S. Correct? Definitely, if A is subset of S, then definitely the number of elements in this A will be less than or equal to n of S, and of course there will be either positive or 0. Correct? Because there can't be negative number of favorable cases. Correct? Either if there is some favorable case, you will write 0, or if there is more favorable cases, you will write n of A is greater than 0. So if you divide this inequality with n of S, because n of S is not 0, because if n of S is 0, which means you are not conducting an experiment. Correct? As long as you conduct a random experiment, there will be some elements in the sample space of the experiment. So if you see, n of A divided by n of S is less than or equal to n of S divided by n of S. So if you see, this is the definition for probability of A is less than or equal to 1, and this is 0. Okay, so this is always true for any event, And in exam, if they're asking you for probability of some event, and if you are getting answers more than one, you should definitely check for your calculations. Okay, because probability of any event always lies in between 0 and 1. Okay, next. If, let me shorten this a bit so you could see the things. Okay, next. If S is the sample space of a random experiment, if S is the sample space of a random experiment, if S is the sample space of a random experiment, then P of S is equal to how much? Means probability of sample space. Means if you take the event as any element in the sample space, then what could be P of S? Means basically this definition. If you see S itself is an event, then N of S divided by N of S. What could be the answer for this? 1. So this tells you that when you conduct a random experiment, definitely one of the outcomes within the sample space will definitely occur. Okay, so that's why P of S is equal to 1, which means whenever you conduct a random experiment, there will be definitely an outcome. And it's obvious, as long as you keep on conducting some random experiments, your outcomes are always present. Okay, so next. I want to tell you one definition here, which was not asked nowadays, but you know, it's in GATE actually. So if there are n elements in a sample space and out of which m elements favor the occurrence of A, then first thing, odds in favor of A is written as n divided by, m way side, so m divided by n minus m. Basically, number of ways A can occur divided by number of ways A cannot occur. So this ratio is called odds in favor. You want an example for P of S is equal to 1, Venkat Sai? So see here, if I say that find the probability that a number between 1 to 6 both inclusive occurs when a die is rolled. So when I roll a die, I am asking you for an event in which both, the outcome is in between 1 and 6 with both inclusive. Means the outcome can be 1 or 2 or 3 or 4 or 5 and it can be 6 as well. So if you see, if you roll a die, definitely the outcome lies within the 6, within the 6 elements. So definitely the probability of my event is 1 in general. Okay. So this is the case. Next, odds against A. Odds against A is nothing but inverse of this. So n minus m divided by m, which is number of ways it can't occur. There's no apostrophe. Number of ways A cannot occur divided by number of ways A can occur. Okay. So these are the total ways actually. So we'll see what are these definitions and all these things in later stages. Okay, because I need to tell you something called complement next. So see here. Third axiom. If A is any event, within a sample space S, then if n of A is the number of elements. If n of a is the number of elements, if n of a is the number of elements that favor occurrence of a, then okay, so see here, then the probability of not happening of a, or you can write the probability of event a not to happen is P of a complement. You should read this as P of a complement is equal to, look, if total number of, see, if n of a is the total number of elements within the sample space, then see one thing, if you want the probability of a not to happen, then you need to write in the numerator number of outcomes that favorable a not to happen, correct? And if you see total, if n of s is the number of elements in the sample space, and out of which n of a is the number of favorable elements for a to happen, then this difference is the number of elements which favor not happening of a, correct, divided by n of s. So if you see, this is 1 minus n of a by n of s, which is equal to 1 minus probability of a. So probability of a not to happen is equal to 1 minus probability of a to happen. Okay, so this is the case. So P of a complement is equal to 1 minus P of a. Okay, yes. So you can write P of a complement is equal to 1 minus P of a. Okay, so see here, clear? So see here. So many of you are asking for example of case 2, means I told you P of s is equal to 1. So let us write, if a random experiment is rolling a die, then the probability of getting an outcome as either of 1, 2, 3, 4, 5, 6 is dash. Means if you see, this particular event which you are talking about is inclusive of all the elements which are in the sample space. So if you see now, P of a is equal to number of elements that satisfy this event is 6, and total number of elements in the sample space is also 6. So this is 1. So basically, if your event is same as the sample space or total number of outcomes in the sample space, then you will get the probability value as 1. That's the second statement. It's just an axiom. There is nothing mathematical proof or something like that for this. So you want me to explain one example of case 3. For example, if I flip a coin, let us suppose the probability of getting head is 1 by 2. So the probability of not getting head means probability of getting tail is how much? 1 minus 1 by 2. Okay. For example, let us suppose probability of a student qualifying gate is 0.2. Then probability that he doesn't qualify gate is 0.8. Okay. Either of the two things should happen. If A should happen, if A doesn't happen, then we call that as A complement. Means if A is happening, that's fine. If not, we say that A don't happen. And the probability that A don't happen is 1 minus probability of A, because total probability is always 1. Okay. Now, if you understand this much, we'll go for something called types of events, which is really important for problems in gate. Types of events. First one, mutually exhaustive events. Mutually exhaustive events. two events, odds in favor is nothing but this ratio. This mathematical definition means number of ways in which this event can happen divided by, see here instead of writing A cannot happen, if you write total number of elements in sample space, this is nothing but the definition of probability of A, correct? But here instead of writing probability of A, we need to know the success ratio, means if these are the number of ways in which A can happen, and if these are A cannot happen, then you see which has more probability, happening of A or not happening of A. So we call that as odds in favor of A. Odds generally denote they are nothing but elements in the sample space. So if you say odds in favor of A, then you see you'll compare the two values, number of ways in which A can happen with number of ways in which A cannot happen. So depending on that, you will take a call whether to conduct this random experiment or not. I mean, to consider this event or not. Okay. So this is just definitions. You can go for them. Next. So see here, two events A and B within a sample space, yes. Within a sample space, yes, are said to be mutually exclusive. Are said to be mutually exclusive. Mutually exhaustive, because we are talking about exhaustive events. If A union B is equal to yes, means if you combine these two sets, A and B sets, you'll be getting sample space again. Okay, so then you call the events as mutually exhaustive events. Example, A is event of getting an even number when a die is old, when a dice is old, and B is an event of getting an odd number when a dice is old. And if rolling a die is the random experiment, what about sample space? S is equal to 1, 2, 3, 4, 5, and 6. So if this is the sample space, when your random experiment is conducting rolling a dice, and if you see, if your A is the event which is getting an even number, which means A consists of the favorable outcomes of A, 2, 4, 6, and set B consists of the favorable outcomes for B getting an odd number and 1, 3, 5. So if you see, this A and B are called mutually exhaustive, because if you write A union B, means if you merge these two sets, this implies A union B is equal to, how to write union of two sets? It's just 7th or 8th class maths. So see, if you see 1, 2, 3, 4, 5, 6, and this is nothing but sample space, yes. So you call two events as mutually exhaustive. When you combine those two events, if you get the sample space, then we call them as mutually exhaustive. Okay. So this is the case. Next, we'll go for one more type, which is mutually exclusive events. Mutually exclusive events means, if you take this complete, if you know a bit knowledge about Venn diagrams, so if you take this as sample space, then if this is A and if this is B, then they are mutually exclusive, means they don't intersect each other. So if you see two events A and B are said to be mutually exclusive, if A intersection B is equal to phi, and generally this phi is the symbol to denote empty set, which is null set basically, which doesn't have any outcomes. So which means if you write this, there is no common point or there is no common outcome in both A and B. Examples: A is getting a prime number when a die is old, getting a prime number when a dice is old, and B is getting a composite number when a dice is old. Getting a composite number when a dice is old. So when you are rolling a die, what's the sample space? Yes. Okay. This is not small s. Let us write capital S. So S is equal to 1, 2, 3, 4, 5, 6. So this is sample space. Correct? Now if you write the elements in A that favor this event of getting a prime number, 2, 3, 5. Next, B is 4 and 6. And 1 is neither prime. Yeah, I'll differentiate prime. That's what I'm telling you now. So if you see, this is A 2, 3, 5 and B 4, 6. And 1 is neither prime nor composite number. So if you see A intersection B, means if you look for common elements in both the sets, you can see clearly there is no common element. So this is an empty set which is equal to 5. So this satisfies this definition. But if you write A union B, which is 2, 3, 5 union 4, 6, you will be getting the set. Union is nothing but writing elements in both the sets. So 2, 3, 4, 5, 6, and you can see this is not equal to sample space. Understood? So which means these elements, you can call them as mutually exclusive events, but you can't call them as mutually exhaustive events. Clear to all of you? Yeah, it's also an example, but I intentionally took this to show you the difference between these two. Okay, some events can be mutually exhaustive as well as mutually exclusive. Both events can happen. For example, if you see here, if I take the events as getting an even number and getting an odd number, then you can see A intersection B is 5 and also A union B is equal to S. So there can be some events where the events can be mutually exclusive and also mutually exhaustive. Okay, so there can be events, no issues. It all depends upon the random experiments and the events that we are focusing on. Okay, so now this is the case. Yes, this before example. Now if you see this mutually exhaustive events, then A union B is equal to S and also A intersection B is equal to 5. So this particular combination of events for this random experiment is mutually exhaustive as well as mutually exclusive because there is no intersection. So did you all understand the difference clearly between mutually exhaustive events and mutually exclusive events? Clear? If yes, please say yes. If you don't understand, you can ask me. I'll repeat again. No issues. Please respond. I want some, 60 people are online. So please say. Clear to all of you? Next, we'll go for something which is called impossible event. Impossible event. So now if you see, the event is said to be impossible. Is said to be impossible if there is no favorable outcome of the event. If there is no favorable, if there is no favorable outcome of the event, in sample space, yes, they are denoted by phi. Generally it is denoted by phi. Impossible events are also denoted by phi because phi generally means null set. Okay, so this implies, see example, if I write the probability of getting a number greater than 7, a number greater than 7 when a die is old. When a dice is old. So now if you see, yes is something like 1, 2, 3, 4, 5, 6. And A is the set of all natural numbers such that n belongs to z plus and n is greater than or equal to 7. So means positive integers and all positive integers which are greater than or equal to 7. So now if you see n of A, is there any favorable event from this sample space which favors this event A to happen? Is there any outcome? Because if you write this set, it will continuously goes on like 7, 8, 9, 10, 11, 12 and all these integers. So if you see, is there any favorable outcome in this sample space? Yes, that can favor this event A? No. So n of A is equal to 0. So then we call this event as impossible event for this random experiment. N is equal to 0. Okay, so this implies P of A is equal to n of A divided by n of S, which is equal to 0 divided by 6, which is equal to 0. So we call, is it possible for neither exhaustive nor exclusive? Yes, it all depends on the choice. Okay, so see here. P of A is equal to n of A divided by n of S, and this is 0 by 6, which is 0. See, all types of events, they completely depend upon the examples that you take, means basically the events that you define here. Okay, so next we'll talk about one important property which is called independent events. Independent events. We'll talk something on this. So see here. Two events A and B. Two events A and B are said to be. Two events A and B are said to be independent events. Independent events if they are from different sample spaces, or if they are from different random experiments. Basically you can say this, from random experiments, and P of A intersection B means probability of happening of both A and B is equal to probability of A into probability of B. So in general, if you see this multiplication in this probability chapter or in permutations and combinations chapter, this multiplication means process is not yet finished, and if you keep plus, then you mean process is already finished. So for example, if you have two sample spaces, this is S1 where you have an event A, and if this is S2, you have an event B here. Now if I want to say that probability of happening of both A and B, see, A intersection B means both A and B, both A and B. A union B means either A or B. Okay, so if I want to say that both these events are happening, then definitely this should happen, and also this also should happen. So this should happen, which means P of A and P of B. So this is P of A into P of B in case of independent events when A and B are two events within two different random experiments. Okay, so this is P of A intersection B. And now before going for next things, I would like to say you something. The number of ways in which, because you may need them while solving problems, the number of ways in which in which r things can be selected, from n different things, from n different things, is given by NCR, and this is equal to n factorial divided by n minus r factorial into r factorial. Okay, you know what are factorials? So if you calculate this formula, this is number of ways in which you can select r things from this n things. Okay, see, for example, if you see, if I have 4 things a, b, c, d, okay, and if I want to select 3 things at a time, now out of these 4 I can select a, b, c, then I can select a, c, d, then I can select b, c, d, and also I can select a, b, d. Correct? I can select a, b, d. So these are the 4 combinations that I can select out of this 4 elements if I choose 3 at a time. So similarly, if there are n total different things, and if you want to choose r, you can choose totally in NCR ways, which is n factorial divided by n minus r factorial into r factorial. Now I want to tell you one important thing at this point. If there are n things, of course different, if there are n different things, the number of ways in which n things can be selected at a time can be selected at a time is dash. See, when you have n things, you can calculate in NCR ways. So now if you have n things, normally also you can see when there are 4 variables that are available, and if I want to select all 4 at a time, I can make only one selection. Correct? Selection is different from arrangement, but if I want to select, I can select only in one way, because whatever the elements are present here, I should take all the things. So this is one way, which means we can write by our definition NCN is equal to 1. Means if there are total n things, then the number of ways in which you can select these n things out of these n things is only one way. Correct? Yes, all of you are correct. So this, if you define this as per expansion of NCR, NCR is equal to n factorial divided by n minus r factorial into r factorial. So if you see, if you divide this, n factorial divided by n minus n factorial into n factorial is equal to 1. Correct? This without this formula. Generally forget about this formula, then if there are n things at a time, and if you want to select all the n things, total one way is the only way you can select all these n things. So if you see, if you calculate or if you evaluate this expression, this n factorial and n factorial gets cancelled. This implies 1 by 0 factorial is equal to 1, and we can write 0 factorial is 1. Okay, as though it doesn't get valid as per natural numbers formula. Like if you have n as a natural number, positive natural number, then you write n into n minus 1 into n minus 2 into and so on 1. But since this is it's like an axiom which need not have proof, we got this 0 factorial is equal to 1. And also there could be one more thing. See, if I write here 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 6, 4 factorial is equal to 24. If I write this, see, to get this 6 as 3 factorial, we need to divide this 24 by 4. Correct? If you divide this 24 by 4, you will be getting 6 as the 3 factorial. Similarly, if you want to get this 2, you need to divide this with 3. Correct? Because if you divide 6 with 3, you will be getting 2, which is 2 factorial. Similarly, if you want to get 1, you need to divide this term by 2, which is 1 factorial, which is 1. So if you want to write 0 factorial, it's nevertheless 4, 3, 2, 1. There's nothing big to change this series or sequence. you can always go for 1 if you divide this with 1, because you're dividing this with 4, 3, 2, and there's nothing contradictory to continue this logic. So this 2, when you for the next term, if you divide this with 1, this 1 remains as 1, and this 0 factorial is defined as 1 in many of the literature in mathematics. Okay, so this is how you can always see the things. Okay, next we would like to write something big. If NCR is equal to NCS, then we'll see where we use NPR. No issues, Monica. So see here, if NCR is equal to NCS, this implies R is equal to S or N is equal to R plus S. Oh, both things are looking the same. So R plus S. Okay. So if you give these two values like NCR is equal to NCS, then either R is equal to S or N is equal to R plus S. Okay. So if you want, you can see quickly how these things gets happened. NCR is equal to NCS. You know, this is equal to N factorial divided by N minus R factorial into R factorial, and this is equal to N factorial divided by N minus S factorial into, okay, let me not write this smallest. In thermodynamics course, I'm writing the smallest nowadays, so I just got habituated. So see here, N minus R factorial into R factorial should be equal to N minus S factorial into S factorial. So for this to happen, you can have two things. One is either R is equal to S, or if you write N is equal to R plus S, even in that case also this equation gets satisfied. So there are two solutions for N. I mean, you know, N is equal to R plus S. If you put here R plus S, then R gets cancelled. So S factorial into R factorial will be same as R factorial into S factorial. Or if R is equal to S, then both this right hand side and left hand side, you'll be getting the same value. So these are different ways in which you could show this result. Okay. One time in GATE examination, this question was asked. You know, they have given this some phi C4 is equal to phi Cx something, and they are asking you for X value. Okay. So see here. Next, tell me one thing. Number of ways of arranging 4 objects in 4 places. See what happens if you have 4 places, 1, 2, 3, 4, for example, and if you have 4 objects, A, B, C, D, different objects, then see in how many ways you can arrange. See, for the first place, you can put any of the 4 objects. Correct? So number of ways you can fill in this place is 4. So you can see total 4 objects. Out of these 4, any of the object can be fitted at first place. This is second place, first, second, third, fourth. Okay, so if you see, any of the object can be fitted at first place. So total number of ways available is 4, and task is not yet completed because you need to fill all these 3 places. So for filling the second place, since you have already put 1 object in this place, you still have 3 objects, which means you can use this place. I mean, you have 3 choices to fill this space. Similarly, if you go here, you have 2 choices to fill this space, and finally you have 1 choice to fill last place. Because see carefully, whenever you are talking about first place, no object is put here. So total out of these 4 objects, you can put any of the object, which means for filling the first choice, you have 4 places. I mean 4 choices to fill this first place. And for filling the second choice, for filling the second place, you have 3 choices, because out of these 4 choices, 1 choice is already fixed here. So you have 3 choices, so you can fill this place in 3 ways. Similarly, 2 and 1. So this is nothing but 4 factorial, which means if I ask you number of ways in which are different things can be arranged in R different, in R places. You can say places will be of course different. In R places is how much? If you extend this logic, How much it could come? R factorial, correct? So this is R factorial. So if you have R different things to arrange and if you have R places, then you have total R factorial ways to work out the things. Now, if I ask you this question, number of ways in which R things can be selected at random. R things can be selected at random out of n different things, out of n different things, and can be arranged is dash. So now if you see, first of all we need to select R things out of this n things, and then after that we should arrange them. So see carefully. First task is to select R things out of n things, so which means NCR. And after selection, is your task completed? No, we need to arrange. So once if you select, then and you should select, and after selecting R things, you should arrange them in this R places. So you can do that in R factorial place. Correct? Number of ways you can select R things out of this n things is NCR into this is R factorial, because total out of this R things that you are selecting here, you need to arrange them. So now if you go for this definition, number of arrangements is equal to NCR into R factorial. So if you write this definition, this is n factorial divided by n minus R factorial into R factorial into R factorial. So now if you can cancel these two, we have n factorial divided by n minus R factorial, which is NPR for this. Okay, so this implies number of, generally arrangement is called permutation and selection is called combination. So number of permutations means the word this permutation means arrangement. Number of permutations of R different things, R things from n different things, is equal to NPR, which is given by this format, n factorial divided by n minus R factorial. And similarly, number of selections or number of combinations you can write, which means basically selections of R things from n different things, is equal to, we have seen just now, n factorial divided by n minus R factorial into R factorial, which is given by NCR. Okay, so clear? So this is permutations, number of permutations that you can have for R different things out of this n different things, and this is number of combinations, basically selections you can have out of this n different things. Okay, you can see by the formula wise it's different, correct? See, for example, if you take three elements A, B, C, and if I have two places, so number of selections I can make is three selections, A, B, B, C, C, A. But number of arrangements, these three are selections, because out of these three, if I want to select two elements, only these are the three possible ways I could select. But if I want to arrange them, we can write AB, BA, BC, CB, AC, CA. All these are 6 arrangements, because these two arrangements can be done with the same selection AB. So these are arrangements. So you see, number of arrangements and number of selections changes. Okay, if I write AB or if I write BA, that means that shows me that I have selected only A and B. But now if I start arranging, the difference in the places could make some sense. Correct? So now I would like to give one statement before I solve few previous gate problems with the definitions that we learned as of now. So let us see that. The number of ways in which n things can be arranged out of which p things are of one kind. All these formulas I think you might have seen in your +1 and +2 levels. So NPI is always greater than NCR, yeah, of course, because you see number of arrangements will be more in general. So the number of ways, because the division r factorial is not there in NPR. Okay, if you compare Kamaluddin, n factorial divided by n minus r factorial into r factorial, this is NCR, and this NPR, if you see, n factorial divided by n minus r factorial. So this is always less than this, because if you see, this r factorial has some positive value, and of course this is more than 1. When r is like 2, 3, 4 number of things, this factorial value will be more. So if this is more, this whole value is less when compared to this. Okay, because this value is more than 1, which is here. Okay, clear, Kamaluddin? Understandable? Clear to all of you? Any issues so far? If there is some issue, please talk to me. Did you all understand everything? Please respond. Around some 57, 58 are online. So please respond. If you are okay with the things, we'll continue. Okay. So, okay, fine. So see here, R of first kind, Q things R of second kind, and R things R of third kind, and so on. For example, is means where total you have n things, out of which, yeah, if r is equal to 1, then they are equal, because 1 factorial is always equal to 1, you know. So because if you are selecting only one thing, you don't have anything to arrange, correct? Number of selections is equal to number of arrangements, because if you are having only one place and one thing to put, then no arrangement is possible here. Whatever you select, you need to put it here. Okay, so this is the case. So we'll see, is n factorial divided by p factorial into q factorial into r factorial. This formula has a derivation, but I would not like to tell you now, because you know these values are generally big. So n factorial divided by p factorial divided by q factorial into r factorial means, for example, if you have, for example, 10 books, out of which 4 books are maths books, and you know, next for example 3 books are physics books, and you know, another 3 books are chemistry books of same kind, then you know, total number of ways in which you can arrange is not equal to 10 factorial, correct? Because these 4 books, whatever the order you put, the answer will be same. Similarly, these 3 books, whatever the order you put, the order will be same. Similarly, these 3 chemistry books of same kind, whatever the order you arrange these 3 books, total arrangement looks same. So if you see, this is n factorial divided by p factorial into q factorial into r factorial. So now if you see the things, with this knowledge, shall we solve some problems now of previous gate questions? And of course, few questions are not previous gate questions. We have put it on our own. So I think we have learned some story within the past 1 hour. So, okay, Vamsi, Kamaluddin and all. Okay, shall we go for some problems? Okay, I think this wire is coming, the mic wire. Okay, so if that's the case, then this is the first problem. Please solve. The number of permutations of all the letters of the word Kamaluddin is dash. Please try to solve this. Let me change color since we are writing solutions for this. So total number of arrangements you can make with the word Kamaluddin. So please tell me this. Ten factorial by 4. See here. If you see this word Kamal, I hope I got your name correct. Correct? Yeah, Udin. So, what are the total number of letters? Total number of letters or total number of alphabets, or you can write total number of things is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. Out of which you see some objects are of same type, DD and all these things. Correct? So if you see now, these two A's are same, these two D's are same, which means out of these 10 things, 2 things are of one kind and 2 things are of another kind. So if you see, yes, you have 2 and D's you have 2 and remaining all other you have 1. K one time, then M one time, L one time and U also one time. So if you see this, number of permutations, which means number of arrangements basically, is equal to total number of things that is available with you is 10 factorial divided by, now 2 times A is getting A is occurring here and 2 times D is occurring here. So 2 factorial into 2 factorial into, and all other elements are occurring only for once. So if you see 1 factorial into 1 factorial into 1 factorial into 1 factorial. Of course, all this product of 1 factorials is 1. So 10 factorial divided by 4. This is the answer. Okay. So now if you want to calculate this value numerically, how much it is, you can calculate using virtual calculator. I'll show you how to calculate that. So please see here. So see here, 10 factorial divided by 4. If you want this value, you can click 10. First of all, you can see 10. And if you see here, there is n factorial symbol. So after clicking 10, if you click this n factorial, you will be getting this answer. 3628800 divided by 4 is what you have. So if you see 907200, which means 907200. So this is equal to 907200. These are the total number of ways in which you can arrange the letters in the word Kamaluddin. Okay. So Kamaluddin, I hope this will be your salary by the end of your final year in the campus placements. Okay. 9 lakhs could be a good package, right? To survive in this situation, in COVID-19 situation. Okay. So now we'll go for next question. Did you all understand this? Why we got this answer 907200? Clear to all of you? Okay. Fine. So this is the next question. If NC4 is equal to NC5, then N is equal to. This is also a previous gate question, you know. Okay. So see here, we have NCR is equal to NCS. This implies either R is equal to S or N is equal to R plus S. We have seen, but here this 4 and 5 are not same, which means this can't happen, which means this should happen, which means N is equal to 4 plus 5, which is equal to 9. So this is a previous gate question that was asked in one of the years. Okay. So next, we'll go for next question. See this. The probability that a leap year selected at random will contain 53 Sundays. So if you see, what is a leap year? What is a leap year? I assume that you know what is a leap year, correct? 366 days, correct? Okay. Okay, so if there is 360 days, 366 days, fine, that leap year will have 53 Sundays. One by 7, let me write. So see here, solution. Now, 366 days, if you write carefully, you will be getting 52 weeks plus pen, your answer is correct. Haishita, you are also correct. Answer is 2 by 7. So 52 weeks plus 2 days, correct? Because this is same as 364 days. Now, in this 52 weeks, definitely 52 Sundays will come, for sure. So which means now out of these 2 days, you should have 1 Sunday. This is the question. So now the question is, in a week, if you select 2 days at random, find the probability that there is 1 Sunday, correct? Because out of these 366 days, if you want to have 53 Sundays, which means out of these 2 days, you should have 1 Sunday. It's not Sundays, it's Sunday. 1 Sunday. Correct? Now, if you select 2 days at random, let us see what's the sample space. We can have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and Sunday, Monday, finally. This is the sample space if you select 2 days in a week at random. Now, A is event of getting a Sunday. So what could be n of A which could favor this coming of Sunday? If you see, this is one element and this is another element, which means you have 2 elements in this sample space which could favor an excess Sunday will come in this 2 days. So number of A is equal to 2, and this implies probability of A is equal to 2 divided by, what are the total number of elements? 1, 2, 3, 4, 5, 6, 7. So this is 2 by 7. Clear to all of you? There is nothing big difficulty in this. If you want to have 53 Sundays, which means out of these remaining 2 days, you should have 1 Sunday. That is sitting. So if you select 2 days at random in a week, you should have 1 Sunday. So this is the sample space of selecting 2 days at random in a week. So out of this, you can see 2 elements are giving you this. N of A is equal to 2. Clear to all of you? Why it's 2 by 7 and why it's not 1 by 7? Because you have 2 possible cases of getting a Sunday in 2 days selected at random. Okay, clear? Did you all understand this? Why it's 2 by 7? See, just I applied the definition of probability after understanding the question. Yes, sir? Clear to all of you? Yeah, for normal year, it's 1 by 7, of course, because you'll be having only 1 day in excess and you want that day to be Sunday, so it's 1 by 7. Next, this is the question. A bag contains 40 tickets numbered. You want me to explain once, Vijay? Okay. So see here. Total, it's given the leap year should contain 53 Sundays. Okay. And you know, the leap year is the year which has 366 days. And this 366 days can be written as 52 weeks plus 2 days. So which means in this 52 weeks, since a week is combination of all the 7 days, this 52 weeks will definitely have 52 Sundays. Plus, now, if there will be remaining 2 days apart from this 52 weeks. So it's not mandatory that these 2 days will have Sunday in them. Correct? So the total number of ways in which these 2 days can occur is the 2 days which are in excess in that leap year after this 52 weeks can be Monday, Tuesday, or any of this ordered pair that I have written here. So now if you see, we want 1 Sunday to be present in these 2 weeks. So I mean in these 2 days. So if you see, you need to look for the favorable outcome which could give you a Sunday out of those 2 days. If you see this, there is no Sunday in these 2 days. Similarly here, and all these 5 cases. But in the last 2 cases, you have 1 Sunday when 2 days are selected at random. So the sample space is basically total number of ways in which these 2 days can happen. divided, that's the sample space, and number of favorable ways a Sunday will occur in this 2 days. So this is total 2/7. So this is the question. Okay, Vijay Sai, clear? Okay, fine. A bag contains 40 tickets, numbered 1, 2, 3, and so on 40, of which 4 are drawn at random. Means out of a bag which is having 40 tickets in this, whose numbers are 1, 2, and so on 40, 4 tickets are drawn at random, which means total number of ways you can select ways of selection, which means drawing out, is 40C4, correct? Because when there are 40 tickets and if you want to choose 4, total number of ways is 40C4. Now let us come to the event, of which 4 are drawn at random and arranged in ascending order. Now these 4 tickets are arranged in ascending order. Okay. The probability that the third ticket is 25. Okay. Means this third ticket has to be 25. Correct? So now see carefully. When you are selecting 4 tickets and when you are arranging them in ascending order, if the third ticket has to be 25, these 2 tickets should be less than 25. And this ticket should be more than 25. The last ticket. Correct? These first 2 tickets should be less than 25 and this last ticket should be greater than 25. Because we are arranging in ascending order, and in ascending order numbers which are less come to the left and which are right, which are higher will go towards right. Which means out of these 3 tickets that you need to select, because 25, this third ticket is already fixed. Means out of this, if you can select 3 tickets such that 2 of them are less than 25. If 2 of them are less than 25, total how many tickets are present here which are less than 25? 24 tickets, correct? So from the first 24 tickets, definitely you should select 2 tickets, and task is not yet finished. From the remaining 15 tickets which are more than 25, if you see total, if there are 40 tickets, then for the fourth ticket to be more than 25, total there are 15 tickets which are more than 25, 26, 27, 28 and so on till 40. So which means out of the remaining 15 tickets you should select 1, correct? If you select any combination in this way, then definitely the fourth ticket is 25th ticket, correct? And which is 1C1 for the 25th ticket, because you need to select this 25th ticket. Now if you select 4 tickets in this combination, let us write 4 tickets in this combination where you are selecting 2 tickets from first to 24 tickets, 1 ticket from 26 to 40th ticket, and 1 ticket which is 25. Definitely this should be selected because you should have that in the third. If you select a combination in this way, then definitely when you arrange them in ascending order, this 25 will be in the third place, correct? So number of ways the event gets occurred, the event, or you can write the event occurs is equal to number of ways you can select these tickets. So see, it's already given, they are arranged in ascending order. Okay, so the main intention is to know what tickets you need to choose. Okay, it's given when you're arranging in ascending order, the third ticket is 25, and arranging, ascending order doesn't have different combinations. There's only one combination for ascending order, correct? For example, if I write 2, 4, 6, 8 is an ascending order, you can't make another another shifting. You don't have another way to write this ascending order. Okay, there's only one way for writing this ascending order. Okay, so into 1 is the case. Did you understand, Chan? In ascending order, yeah, that's what I'm telling. Monica, see here. Here we don't have any choice to permutate once we know the tickets, correct? Because if I have this, then ascending order is fixed. I can't interchange 4 and 6 again. I can't have another permutation. It means, for example, I can't say that this as a permutation and this is ascending order. No. Okay, we have only one choice for ascending orders. I hope you understood, because for ascending orders you can't have different combinations, because in question it's already mentioned ascending order. So which means out of the available tickets you should definitely put the least at the leftmost and you should put the higher at the rightmost. Okay. So this is 24C2. Yeah, Chan and Morning. No, you understood. So 24C2 into 15C1 is the total number of ways. Into 1, of course, 1C1. You can write this. Anyhow, this value is 1. So now total probability is, let me shorten this to write the probability here. Not this much shorten. Let us enlarge this. Okay. So this implies P of A is equal to 24C2 into 15C1 into 1C1 divided by 40C4. You can calculate this value. If you want, I'll calculate for you. So see here, 24C2 is, see, generally if you have 4C2, you will be writing 4 factorial divided by 2 factorial into 2 factorial, correct? But this is same as 4 into 3 divided by 2 into 1. Okay, means if you are asking for 4C2, you can write till 2 digits and this factorial in the denominator. Okay, so 4 into 3 divided by 2 into 1, because this is same as this, because this 2 factorial which we are writing here will get cancelled after you write this 2 factorial here. Okay. So that's why 24C2 can be written as 24 into 23 divided by 2 into 1 into 15C1 is 15 into 1C1 is 1 divided by 40C4 can be written as 40 into 39 into 38 into 37 divided by, let me erase this a bit. Four into 3 into 2 into 1. So now you want to calculate this value. Okay, so please try to calculate. This is 12 times. So then this denominator goes off. This is 10. This is 13. And this is 19. So if you see 12 into 23 into 15 divided by 10 into 13 into 19 into 37. You can calculate this value. 0.045 is the answer. Okay, let me calculate once. 12, 23, 15. So 12, 23, 15 divided by what's the numbers that we have here? 10, 13, 19, 37. Okay, 10, 19, 13, 97. I mean 10, 13, 19, 37. Okay, so 10, 13, 19, 37. So this is the value. If you see 0.045, which many of you mentioned here, so 0.0453. So this is equal to 0.0453 is the total probability that you can make a selection from these 40 tickets such that this condition gets satisfied. Okay. Is there any difficulty with this question to any of you? Did you all understand? See, denominator is very simple to understand. When you have 40 tickets, you need to select 4 tickets, so 40C4. But did you all understand why this numerator is this? If you understand this numerator, then I'm happy for this. Then this is just a calculation part, mathematical calculations, some multiplications and cancellations you can do. Did you all understand why this is coming here? If yes, please say yes. I want some 59 on live. So please tell me, did you all understand why I have written this here? Okay, so now we'll go for next question. See here, a 5-digit number is formed by the digits 0, 1, 2, 3, 4. Okay, without repetition. Okay, so they are not repeating the digits. The probability that the number is divisible by 4 is dash. So tell me, try to solve this and tell me the answer. Just apply the basics. Okay, apply. See, first of all, find total number of ways, then find number of favorable ways. The ratio is probability. That's it. Simple questions. Only, generally people feel probability difficult because, for example, if let us suppose I'm talking about limits. If I give you one formula, with that one formula, you can solve 10 questions. But probability and permutations and combinations is not such cases. You need to think carefully for every question. That's the only thing. Formula is same. Total number of cases and number of favorable cases divided by total number of cases. That's the only formula to find probability. But the main art is to identify what are number of favorable cases and what are total number of cases. And you can do that if you understand the questions carefully. So please try to do this question. One by 20, Suma, which means you mean to say 0.05. Okay, maybe. Let me check. Solve. I want some 58 online. Don't wait for my solutions. Okay, I know how to solve this question. Okay, you need not, examine me. I know how to solve this question, but I want you to solve this question. Anyhow, I'll solve if you can't. Not getting? Suppose if this question came in your GET exam, what will you do? If there is no option like not getting, then what will you opt for? Try 1 by 24, 1 by 20, 3 by 4. Okay, different answers are coming. So let me check. What could be the actual answer? See, first of all, if you want to know the number has to be divisible by 4, for that you need to know what are total number of 5-digit numbers you can form. 5 by 16, Harshita. Okay, let me check. Total number of 5-digit numbers. Total number of 5-digit numbers you can form is equal to, see here, there are 5 digits, 5 places, and the digits that is with you are 0, 1, 2, 3, 4. 11 by 48, 5 by 16. Okay, let me see. 1 by 5. Okay, let us see what could be the correct answer. Okay, because to be frank, I didn't remember, so we need to solve. So these are 5 places, and we have 5 digits to form a number. Correct? Now, for filling the first place, how many choices I have? Please tell me. Okay, don't forget about answer for some time. Let us see the working procedure. If I want to form a 5-digit number using these digits, tell me how many choices I will have to fill this first digit. 4. Correct? Into next. To fill this second digit, how many choices I have? To fill this second digit, how many choices I have? Because how many objects are left with here? 4. So I can fill this digit in 4 places. For this third, for filling this third place, how many digits I have? For filling this third place, if I fill 2 digits here, I will be having 3 more digits left. Similarly for this 2 and for this 1, which means 4 4s are 16, 16 into 3, 48, 48 into 2, 96 5-digit numbers I can form using these digits. So total number of 5-digit numbers you can form is 96. Repetition is allowed. Monica, please read the question carefully. Without. Okay. So see here. Now, if total 96 5-digit numbers you can form, I think Bharat you are correct, 0.3125 something. So see here, 96 5-digit numbers. So see here. Now, if you want to form a 5-digit number which is divisible by 4, look. If you recall your divisibility rules, tell me what should be the last 2 numbers. What's the divisibility rule for 4? The combination of these last 2 numbers should be divisible by 4. Correct? Which means out of these numbers, if I have 04 or 08, but 8 is not present, so 12. Next 16, 16 is not present, so 20, and then 24, and 28 is not present, then 32, 36 is not present, so 40, and next it's 44, but repetition is not allowed, so 44 we can't take, 48, 8 we can't take because 8 is not here, and then after 52 and all numbers increases, which means out of these numbers I can form 5-digit numbers that can end with 0, 4, 1, 2, 20, 24, 32, 40. If I know total how many numbers I can form with last 2 digits as this combination, then I know total number of 5-digit numbers I can form which are divisible by 4 using these digits. Did you all understand? So why first by choice is 4? Because out of this 5, if I put 0, then this number won't be a 5-digit number, which is high, it's a 4-digit number. Okay, so for filling this first place, I can't have these 5 choices, because if I put 0 here, then it won't be a 5-digit number anymore. Okay, so I can put only either of 1, 2, 3, 4 in this place. So now, if I form a 5-digit number in which last 2 digits are any of these choices, then definitely the number is divisible by 4. Because a number is divisible by 4 if the last 2 digits are divisible by 4. So now 0 is already utilized here. So how many choices I have to fill this place now? From the remaining 3 choices, see, 2 digits I have already used and I have fixed here. So please tell me how many choices I have to fill this place. Three choices, correct? Next, to fill this, I have 2 choices, and to fill this, I have 1 choice, which means you can form 6 numbers totally, which can have 0, 4 in the ending and using these digits. Next, if there is 1, 2 here, now please tell me how many ways I can fill this digit. If there is 1, 2 here, now please tell me how many ways I can fill this digit. 2 ways, correct? Because I can't put 0 here. So this is 2 ways. Next, here again it's 2 and finally it's 1. So total 4. See, Sushant, Sipana, see here, I can't use 3 here because 0 is not utilized here, which means if I take 3, there is a chance that 0 might come here and it won't be a 5-digit number. Okay. So next, 0 is already included here, so we can form 6 numbers similar to this. 0 is not included here, so we can form only 4 numbers. 0 is also not included here, which means you can form only 4 numbers, and 0 is included here, which means you can form 6 numbers. See, when 0 is already included in this 2 digits, you got 6 numbers, and when 0 is not included, you got 4 numbers. Similar is the case for all these 3 choices, which means if you add 6 plus 4 is 10, 20, 30. So total it is 30. So 30 numbers are the total number of 5-digit numbers you can form using these digits. 0, 1, 2, 3, 4, which are divisible by 4. Okay, so probability is 30 by 96. See, Vijay Sai, first tell me, did you understand this? Why this is 96? Please say yes or no. Vijay Sai, I am talking to you. Please tell me whether first of all did you understand this 96 5-digit numbers or not? How this is 96? Okay. Now, if you understand this, now see here. You want to form a 5-digit number. Forget about all these things. Look at this first thing. You want to form a 5-digit number out of which last 2 digits are 0, 4. Then, if 0 is already utilized here, now out of 5 digits, 2 digits are already utilized, 0 and 4, which means the remaining digits that are left with you is 1, 2, and 3. Now, using these 3 digits, you need to fill in these 3 places. So, total you have 6 ways, which is 3 factorial. But for the second case, if you see, the final digit is 1, 2, means you need to fill 3 digits with the numbers 0, 3, and 1. You need to fill these 3 places with these 3 digits in this second case. So for filling this digit, you can't put 0 here, because if you put 0, this will be a 4-digit number. So out of these 3 digits, you can put only 2 digits, which are 3 and 1. So now for the remaining 2 digits, you can put any of the numbers. So we'll be getting 4 numbers, which are ending with 1, 2. So if you follow this logic, whenever you are getting this 0, means if 0 is already present in this 2 digits, then 0 can't come here, which means you can form 6 numbers, and finally if 0 is not coming here, you can form only 4 numbers. So 0 is coming, so 6, not coming, 4. Here it's not there, 4. So total, if you calculate, you will be getting 30 5-digit numbers which are divisible by 4 using this method. Okay, so this is 30 by 96. Clear? See, for some of you, video is lagging, I think, because you may go back doing live if you don't understand something or things like that. So When you are already lagging, please wait, because I might have explained it again, which you don't know at that moment when you are seeing the video. Okay, so please see this. So sixth question. A bag contains 8 blue and 6 white balls. So there are 8 blue balls and 6 white balls. Now, the probability of drawing 2 balls of same color. The probability of drawing 2 balls of same color. What's the value of that Haishta? Tell me. 8C2 into 6C2 by 14C2. What's the value of that? 43 by 91, Mauli? Okay, so let me check. Total number of ways. Is equal to, look, you have total 14 balls which are inside this basket. So if you want to take 2 balls of same color, first of all, let us find in how many ways you can take 2 balls out of this bag. So if there are total 14 balls, then if you are selecting at random, then you can, total number of ways you can select the 2 balls is 14C2. Means out of 14 balls, you need to take 2 balls. Now, let us calculate number of favorable cases. Number of favorable cases is equal to, look, now there are 2 possibilities for this event to happen. Correct? First possibility is you can choose both blue balls, or second possibility is you can choose all 2 white balls. So number of ways of choosing 2 blue balls is 8C2. You want to select 2 balls finally, and 2 ball selection is already finished, which means the event is finished. This is one possibility. Or there is one more possibility. See, when I am telling this, or I am putting a plus sign because this is an alternative possibility. Correct? So this event can happen, means drawing 2 balls of same color can happen in 2 ways when you select either 2 blue balls or 2 white balls. So this is the number of ways in which you can select 2 blue balls. Similarly, you can select 2 white balls in these many number of ways, because total 6 white balls are present and you need to select 2 out of 6. So this implies probability is equal to 8C2 plus 6C2 is the total number of ways in which you can select 2 balls of same color, and divided by 14C2, which is equal to 8 into 7 plus 6 into 5 divided by 14 into 13. So if you calculate this value, 7 is 56 plus 31. 56 plus 31 is something like 87 divided by 14 into 13. You can calculate the value. 196 minus 14 is 182, I guess. So 87 by 82. 87 by 182. 86, 56. Acha, this is 30, correct? So 86 by 182, correct? Then you can, 86, correct, all of you. So 86 divided by 182. Okay, so what's the answer for this? You can cancel 2 table, 43 and 91. So 43 by 91. I think you should get something around 0.46 or 47. 0.472, okay. 0.472 is the answer for this. Clear? For every question, are you all understanding how I am identifying number of favorable cases and how I am writing total number of ways for that to happen? If you understand that, then things are going fine. 7. A fair die is rolled twice. The probability that an odd number will follow an even number. Okay, if yes, please solve this question. Don't miss second session today, because we'll talk something about conditional probability and Bayes theorem. Okay, those two are really important as far as gate, and problems comes very frequently on them. Anyhow, I think in many of your homes there will be solar eclipse restriction today, so you can't eat or do the things. So we'll attend the class. Okay. One by 4 is the answer. Okay, let me check. See, a fair die is rolled 2 times. So let us suppose first time and second time. And second time, correct? Now, the probability that an odd number will follow an even number means in the first, you can say first out and second out better. Okay, so there are there is a die and you are rolling it 2 times. So in the first roll, see what he's asking for. The probability that an odd number will follow an even number, which means in the second roll it is odd number, and in the first roll it is even number. Correct? Now tell me, these two events are dependent or independent? Means the second, what's the outcome on the second roll is depending on the first roll or it's not? Actually, when you roll a die for 2 times, second roll outcome is independent of the first roll outcome, correct? So these two are independent. Okay, now see carefully. He is asking for P of A intersection B, means A should happen and B also should happen. Means if odd number want to follow this even number, then definitely in the first roll you should get an even number, and in the second roll you should get an odd number, which is equal to P of A into P of B, because this is independent events. So probability of getting an even number in the first roll is 1 by 2, because 2, 4, 6 and 1, 2, 3, 4, 5, 6. So if you see, probability is 1 by 2. Here also probability is 1 by 2. So this is 1 by 4. This is as per independent definition, or if you want to apply basic definition of probability and if you want to answer this, you can still answer. When you roll twice, total number of sample space elements are, in the first roll it is even, second roll it is odd. First roll it is even, second roll also it can be even. First roll it can be odd, second roll it can be even. First roll it can be odd, second roll also it can be odd. So these are total 4 possibilities when you roll 36. What is 36? I didn't ask the question yet. What is 36 and 86, all of you? So see here carefully. When you roll die for 2 times, first time it can be even and second time it can be odd. Similarly, first time it can be even, second time also it can be even. First time it can be odd and second time it can be even, and finally both can be odds. So total number of elements in the sample space is 4. Out of which he is asking the probability that an odd number will follow an even number. Means the odd number will follow an even number means first trial it should be even, and in the second trial it should be odd, which means n of A is equal to 1. So P of A is equal to 1 by 4 by definition. Okay. Because when you roll a die, either it should be even number or odd number, correct? So you have 2 possibilities. Break at 9:45, Mauli. I told you class is from 7:45 to 9:45, and Next class is from 10:30 to 12:30. Okay. Okay, so we'll talk something now that is important to us. Something we call as additional theorem of probability. Additional theorem of probability, which is important to us. And after learning this theorem, we'll solve two problems. Then I think by that time will be 9:45. We'll go for a break. Okay. Additional theorem of probability. So, what is additional theorem of probability? So let us see. If E1 and E2 are two events within a sample space S, within a sample space S, then P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. So this is the case, which means, see here carefully, if you take a sample space yes, and if this is event E1 and if this is event E2, you know events are subsets of sample space and these two events can have some common intersection as well, no problems. So if E1 and E2 are two events, then see carefully. If I want to write number of elements in E1 union E2, this is nothing but E1 union E2 is nothing but this thing, correct? The shaded region. Now I can write this as n of E1 means, if I change color, see here, n of E1 means I will be considering this shaded region plus n of E2, I am considering this shaded region. But now, if I am adding these two, one part is getting repeated, correct? What is that part? If I want to calculate this total region, I am adding these two regions independently. So if I am adding these two regions, then one portion is getting repeated in this calculation. What is that portion? Could some of you tell me what is that portion that is getting repeated when I am adding these two? Common part, which is E1 intersection E2, which means this part which we are talking is getting repeated, correct? This portion is getting repeated for us. So if you see plus n of E2, so if you want to equate this result to this, minus n of E1 intersection E2, correct? It's like a square plus b square is equal to a plus b whole square, and since plus 2ab term is excess in this, you are subtracting 1 2ab. Similarly here, if you want to calculate this complete region, then this can be written as this complete region of E1 plus this complete region of E2 minus this common intersection part. Correct? All of you are correct. So now if you see this, if you divide this equation with n of s, okay, since n of s is not equal to 0, because we are conducting some random experiment, since this n of s is not equal to 0, we can divide this. And by definition, this is nothing but probability of E1 union E2 is equal to, now since this is a common denominator, if you split this denominator for all these three terms individually, n of E1 divided by n of s is P of E1 plus n of E2 divided by n of s is P of E2 minus this is P of E1 intersection E2. So this result is called additional theorem of probability. Okay, so this is additional theorem of probability. This isn't. Okay. Now, in this, we'll see a special case. Means if there are three events, if E1, E2, E3 are three events within a sample space S, within a sample space S, then P of E1 union E2 union E3 is equal to, similarly if you draw a Venn diagram, you can see the things. So I'm just giving you Venn diagram. Later you can check if this is E1, this is E2, and if this is E3, E1, E2 and E3, then you know, and if this is sample space, yes, you can write P of E1 plus P of E2 plus P of E3 minus P of A intersection, E1 intersection E2 minus P of E2 intersection E3 minus P of E3 intersection E1 plus P of E1 intersection E2 intersection E3. This is the result. If you want, you can check. Means basically, if you want to check this E1 E2 E1 union E2 union E3, means if you want to check what's the value of this region, complete region, this value should be equal to something which I have written on the right hand side. E1 plus E2 plus E3 minus intersection E2, this plus common intersection part of all these three. Okay. So this is the case. So for two events, let us see different cases. For two events, additional theorem of probability is additional theorem of probability is additional theorem of probability is P of A union B is equal to P of A plus P of B minus P of A intersection B. Correct? Because we can denote with either E1, E2 and so on, or A and B. Now, case 1. If A and B are mutually exclusive events, then what about A intersection B? Please tell me, if A and B are mutually exclusive events, then what is A intersection B here? Please tell me, all of you. 5. This implies P of A intersection B is equal to 0. So if you write P is equal to, P of A intersection B is equal to 0, this implies P of A union B is equal to P of A plus P of B. Okay. So the additional theorem of probability gets equated to this. So similarly, if you apply for three elements, P of E1 union E2 union E3 is equal to, if E1, E2, E3 are collectively exclusive events, means if there is no common intersection between E1, E2 and E3, then all these four terms will go to 0, and P of E1 union E2 union E3 is equal to P of E1 plus P of E2 plus P of E3. So if you want to write this answer in generalized format, if E1, E2, E3 and so on, En are collectively exclusive events, or you can write mutually exclusive. Means if you take pairwise exclusive events, better, pairwise exclusive events in a sample space S, in a sample space S, then P of E1 union E2 union and so on En is equal to sigma I is equal to 1 to n P of Ei. Correct? Which is same as P of E1 plus P of E2 and so on plus P of En. So this is the standardized result for any n events which are pairwise exclusive. Okay, so in a GATE examinations, they'll be giving you 2 events or 3 events, and they'll define you that they are collectively or pairwise mutually exclusive. So then P of A union B is same as this. Okay, next, if A and B are, you can write case 2 here, case 2. If A and B are independent events, if A and B are independent events, then please tell me P of A union B is equal to P of A plus P of B minus P of, then P of A intersection B is equal to P of A into P of B, correct? Because if events are independent. So this implies we have minus P of A into P of B. So now if you take one P of B common from this, P of B into 1 minus P of A, and this 1 minus P of A is called A complement. So P of A plus P of B into P of A complement. So this is a result. In exam, they'll give you 3 things and they'll ask you for they'll give you A union B and P of B, then you'll ask for P of A. You can use this expression. Okay, so things like this are asked in GATE examination, just like playing with the complex, this complement symbol and all these things. You can always go for such results. Okay, before going for next question, I would like to say one problem for you. One result. If A and B are events within a sample space S, events within a sample space S, within a sample space S, then P of A complement intersection B complement. Could someone tell me what's the answer for this? See, take the help of a Venn diagram. This is A and this is B, for example, and this is S. Okay, so now what's the probability of A complement intersection B complement? Please tell me what's the value for this? See, around some 48 people are on live. So please tell me what would be the answer for this? One minus P of A union B, correct? Yeah, P of A union B whole complement means 1 minus P of A union B, correct? So this is 1 minus P of A union B. Okay, because see carefully, A complement intersection B complement is this area, if you see clearly. Because normally if you see, if I write this as A and B, and if I ask you what is A complement, then you will be writing something like this. Correct? This is A complement. So if this is A complement, then similarly B complement will be something like this. If this is A, B, and if this is B, and if this is A, then this region basically. So this region, this is B complement. Correct? So if you want to write the common portion of these two, then this is the common portion. Correct? Because everything, if you see, everything out of this is common for both these diagrams, correct? Because it is shaded. The only difference is lying here. So this is nothing but 1 minus P of A union B. And this result is important because you have formula for this now. P of A union B formula you have, so you can calculate this result always. Okay, so with the help of this, we'll go for 2 questions and then we'll take a break. Okay, so please solve this. Solution. Please try to solve this question. If A and B are independent, if E1 and E2 are independent events in a sample space, yes. And if P of E1 is equal to P of E2 and P of E1 union E2 is equal to 1, then P of E1. So calculate the value P of E1. One by 2, Divya. So let me check. We have P of E1 union E2 1 or 1 by 2. Okay, let me do this. So P of E1 plus P of E2 minus 0.5, correct? So 0.5 is the correct answer for this, I guess. So see here. So P of E1 union E2 is equal to P of E1 plus P of E2 minus, since it's given both are independent events, this P of E1 intersection E2 can be written as P of E1 into P of E2. Given, yeah, 0.5 is the correct answer. Given probability of event 1 is same as probability of event 2 in the question, and P of E1 union E2 is also 1. So if you substitute all these things here, 1 is equal to P of E1 plus P of E1 minus P of E1 whole square. So now you can get the value of P1 because this is an equation in terms of single variable. So this implies 1 is equal to 2 times of P of E1 minus P of E1 whole square. So this implies probability of E1 whole square minus 2 times of probability of E1 minus or plus 1 is equal to 0. Okay, so probability of E1 is equal to 1. But if probability of E1 is 1, then what about probability of E2? Which means basically E1 and E2 are same events within 2 different sample spaces. Means the case is something like, if this is a sample space and if this is E1 and this is E2. But if this is E1, then you know the sample space itself is E1 for this. So this complete event is E1 and this complete is also E2. This implies P of E1 is equal to 1. Okay, because P of E1 minus 1 whole square is equal to 0. Okay, since minus 2 is not possible for this equation. So see here. This is the last question we'll deal before break. So please solve this question and we'll go for break. Please try to solve this question, all of you. .3 is the answer. Okay, so let us read the question. In view of COVID-19 pandemic, the probability that a state government cancels SSC exams is 0.6, which means probability of already cancelled, but I didn't mention Andhra Pradesh government. Okay, so please, I have mentioned only a state government. I didn't mention your state. So see here, probability of SSC cancelled is equal to 0.6, and probability of +2 exams getting cancelled is 0.4. Okay, because generally, probability of cancelling inter exams will be less, because for engineering people move across the states, but for +2 they generally lie within the same state, so probability to cancel this will be less. So if this is the case, then what it's given, the probability that the government cancels either SSC or 10+2 is 0.7. so SSC union 10+2 is 0.7. so he is asking for P of A intersection B, means SSC intersection 10+2. You can apply additional theorem of probability and you can get answer as 0.7 is equal to 0.6 plus 0.4 minus x, where x is P of A intersection B. So this is 0.3. So the probability that they'll cancel both the exams is 0.3. Okay, which is here. Okay, they cancelled in Andhra Pradesh, but there are few states which are planning for exam. Okay, yeah, yesterday some good Vamsi, you remembered me this. So in yesterday one question we are stuck with, correct? A matrix P is satisfying P cube is equal to P. Okay, then eigenvalues. Options are something like 1, 1, minus 1, and B is something like, I guess, 1, then 0.5 plus I into root 3 by 2, comma 0.5 minus I into root 3 by 2, means 0.866 value is actually I into root 3 by 2, and C is, I think, 1 comma minus 0.5 comma I root 3 by 2, and this is minus 0.5 minus I into root 3 by 2, and one answer is 0 comma 1 comma minus 1. Now this is the question. Actually in GATE examination this is the actual question. There is no some excess part. Okay, but this question was asked in 2016. I was not able to, I'm not eligible to write GATE at that time, of course, for 2016, but this question still has multiple options. Some I have seen different institutes and all at that time that were giving answers for this. There's something called Cayley-Hamilton theorem, which we know, all of us. Cayley-Hamilton theorem. What does Cayley-Hamilton theorem tells us? Every matrix satisfies its characteristic equation. This is what Cayley-Hamilton theorem tells us, correct? Satisfies its characteristic equation. Correct? This is what we know. Cayley-Hamilton theorem, it's a basic theorem, so I didn't teach you because you see in class 12, 11 at that level, so I didn't teach you this. So what they have assumed is this P cube minus P is equal to 0 because P cube is equal to P, and since they assumed that this is a characteristic equation, okay, and means if this is the equation, then lambda should satisfy this equation. So if you take lambda common, lambda square minus 1 is equal to 0, which means lambda is equal to 0, 1 or minus 1. This is what they did, and they have opted for option D, but it need not be mandatory like this. Okay, this is just a matrix which is satisfying P cube is equal to P, correct? In the question they didn't mention that it should not be a singular or it shouldn't be non-singular. If they don't mention that, then we have a chance that this matrix can be a non-singular matrix, correct? If this matrix is non-singular matrix, then inverse exists for this matrix, correct? If inverse exists, then I can write P square is equal to I, because P cube is equal to P. So if you multiply with P inverse on both sides, if matrix is non-singular, which is not mentioned in the question, so it can be a singular or non-singular matrix. But this is the assumption for matrix is singular, which is assumed by the institute's solutions. Okay, but not given in GATE examination. So if you see, since if this P cube is equal to P, then the P can be a non-singular matrix as well, correct? P is not equal to P inverse, but see, if you multiply with P inverse on both sides, what could happen? P inverse into P cube is P square, is equal to I. Okay, Monica. So see here, if p square is equal to I, see what happens. I can write one more equation, minus p square, minus p plus I is equal to 0. I can write this equation also because it's not given that p is singular matrix in the question. So if I assume p is non-singular, then definitely inverse exists and this p square and I gets cancelled. Then if I take this as the equation, or maybe plus here and minus here, then plus here and minus here. Then if you solve this equation, you will be getting 1, 1, minus 1 as roots, which is in the first option. Similarly, if you go for some other manipulations like this, you may get the other two options as well. Okay, I have checked today morning. So if you see, there need to be one word in this question, like P is a singular matrix, something like that, to get unique solution for this question. Okay, if that's not the case, then we have some multiple options that are available, as we discussed yesterday, the same thing. Okay. Or you can write minus p square plus I, doesn't matter, depending upon the algebra of the equations. Then the solution changes. If you put minus signs here, better. Minus p square plus I gets cancelled, so this is 1. So if you see, roots of this equation is 1, minus 1 and 1 again, 1, 1, minus 1 basically. So there are multiple options for this question, which is the same thing that I told you yesterday. Okay, it might have given in the question that P is a singular matrix. If P is singular, then definitely 0 will be one eigenvalue and 0, 1, minus 1 would be the answer. But it's given only P cube is equal to P. So if this is happening, then you can't assume that this itself is the characteristic equation. I mean, lambda can be satisfying this equation. Okay. Yes. Yeah, we can get option A. That's what I told you, Monica. Okay. And you see this 1, 1, if you see 1 can be written as 1 by 1, which is of basically all these three are of unit modulus. Okay. Because if p square is equal to I, then that of p can be plus or minus 1 again. So if you see, product of eigenvalues is minus 1, where determinant can be minus 1 here. So yesterday, out of these two options, to eliminate one option, I thought there could be some excess part in the question, but actually this is the question in GATE exam, but we'll be left with two options like this. Did you understand why this question can have multiple options, first of all? But this was asked in 2016. If something is happening like this, then we can't say that this is the higher order equation that's happening directly. So there are multiple options for this. Okay, so if you understand this much, we'll meet at 10:30 again, and then we'll discuss Laplace transforms universality. After this probability and statistics, we have one more chapter which is called numerical methods. So after finishing that, we'll go for transform theory. Okay, I'll discuss Laplace transforms there. Okay. Yes, we can't say directly that this is the characteristic equation. Of course, if this is a characteristic equation, then this gets satisfied. But if this is the case, it need not be the case. Again, like this is the characteristic equation. Okay. If something is given like this, it doesn't mandatorily means this, because this can also be a possible solution for this. Because in the matrix it's mentioned, it's not mentioned either it's singular or non-singular. Okay. So then, if that's fine, please say yes. If there is something. If there is something, we'll look ahead. Okay, so we'll meet at 10:30. So all of you can join me at 10:30. But 10:30's class is important because we'll deal something called conditional probability, where questions are very often in GATE. Okay, so you can attend. See, the difference between live attending and later seeing the video is, in live you can ask something if you don't understand something. Okay, but in recorded videos later, that may get responded or may not. Okay, so please attend the live. Thank you. Satish Garu.